Hello everyone, hope you all are doing great. Guys, today in this video I am going to make you understand the concept of EtherChannel. We are going to discuss each and everything about this technology, EtherChannel technology. As you know, EtherChannel is a technology which we are using nowadays, right? So it is very important for network engineer to understand everything about EtherChannel. So in this video I am going to make you understand all protocols. If I will talk about the level of this video, right, of this topic EtherChannel, so you can say we are going to understand EtherChannel from CCNA to CCIE. As you know, CCIE is an expert level and CCNA is an associate level. So from the scratch to advanced, we are going to understand everything. Like, as you know, we have some protocols in EtherChannel, PAGP and LACP. We are going to understand both protocol. We are going to understand the static EtherChannel, right? We are going to understand the load balancing. We are going to understand L2 and L3 EtherChannel, right? Everything from the scratch to advanced level you will understand in this video. So if you want to learn, make sure you will watch this video till the end. We are going to understand load balancing as well. As you know, we have multiple types of load balancing in EtherChannel, right? We have multiple types of load balancing algorithm, like source based load balancing, destination based load balancing, source and destination based load balancing, source port load balancing, destination port load balancing, right? Source port, destination port load balancing, everything we are going to understand. Fine. So first of all, we will understand why we come up with this protocol, this technology EtherChannel. Why? Then we will understand what is EtherChannel, and then we discuss how its work, right? We are going to cover both why EtherChannel, after that what is EtherChannel, and then how EtherChannel works. So guys, without wasting our time, let's begin. Make sure you will watch this video till the end. Please keep somewhere along, right? If you are watching this video with a glass of maybe water or with a bottle of water, and please watch till the end, right? Then only you will understand everything. And I am make sure if you will watch this video till the end, you don't need to learn EtherChannel in your life again, right? Because here I am going to make you understand everything practically. Okay, so you don't need to remember something, right, like protocol or anything. You will understand. I am going to make you understand everything directly. Okay, so guys, without wasting our time, now it's time to start. So see, suppose I have two switch 1 and switch 2. Suppose here I have connected one fast Ethernet link between switch 1 and switch 2. I have connected one link, fast Ethernet link, right? This is suppose 0/1, this is 0/2. On this switch number 1, I have connected suppose 100 user over here. How many user? 100 user. Here also I have connected how many user? 100 user. Fine, 100 user are there, 100 users are there. So suppose all user will send traffic on this link at the same time. So how many bandwidth one user will get? One user will get bandwidth 1 Mbps bandwidth, because total bandwidth of fast Ethernet link is 100 Mbps, yes or no? And if 100 user are sending traffic at the same time on this link, every user will get bandwidth of 1 Mbps. Fine. But suppose here, if here we have 1000 user, and if you are thinking that how to connect 1000 user through a single switch, guys, you can consider it like suppose this switch is connected with another switch, this switch, another switch, and here are user. Fine. Suppose 1000 user are there, and in the same way 1000 user are there. This time tell me how many bandwidth each user will get, because we have only one link between switch 1 and switch 2, right? And if this user wants to communicate with this user, they need to use this link, right? And suppose this switch is connected with one router and this router is connected with ISP. So whenever these user will access internet, they have to use this link, right? So maybe on this link you can observe some congestion, right? When multiple people will try to access internet at the same time, or when multiple people will try to communicate with these people at the same time, here you will see congestion is occurring, right? Definitely congestion will occur on this link, yes or no? So what I can do, I can connect one more link over here between switch 1 and switch 2. So what will happen if I will connect two link? Okay, let me use one more link over here. This is suppose F0/1, this is F0/2. Here I have connected one more link, 0/1 and 0/2 and 0/1. This is 0/1. Fine. Now what STP will do, as you know, by default a spanning tree protocol is running over here, right? On this switches STP is running. So suppose MAC address of this switch is 0A, MAC address of this switch is 0B. This switch will become what? Root bridge. This port will become DP, this port will become DP, this port will become what? RP, and this port will become alternate. So STP will block the alternate path. Yes, this path. Again, all user will use only this path. Even you will connect 8 link between these switches, STP will allow you to use only a single link, right? STP will block 7 link, right, between switch 1 and switch 2. So you have an option to disable the spanning tree protocol. You can disable it, but if you will disable a spanning tree, definitely loop will form between switch 1 and switch 2, right? And this is layer 2 for loop, guys, right? So for lifetime traffic will be moving around between switch 1 and switch 2. So we cannot disable a spanning tree protocol, right? Now my requirement is I want to use multiple link between switch 1 and switch 2, right? I want to use STP as well to avoid loop, and I want to use all link together, right, to get more bandwidth between switch 1 and switch 2. So now EtherChannel will come in role. What EtherChannel technology tells? It tells that you can bundle these all link together, right? You can bundle all physical link together, and by bundling you will create one logical link. Let's say P1, and here also it's, let's say, P2, right? It is locally significant. We can use any number. Suppose here I have created logical port 1, here I have created logical port 2 by bundling these 8 link together. So this is your logical link. So now in between switch 1 and switch 2 I have a logical link, single logical link, right? P2 and here P1. Now STP will learn on this port, right? So this port will become what? Again DP, and this port will become what? RP. Now in this logical link we have these 4 physical link, right? So when data will flow, it will use all 4 physical link, but loop will not form here. How loop will not form? For that EtherChannel will run their internal loop avoidance algorithm. Let me make you understand that first, then only I can make you understand what is EtherChannel, guys. First try to understand why we need EtherChannel. Okay, so why we need EtherChannel? We need EtherChannel so that we can connect multiple links between switches, and we can use all links, right, to get more bandwidth. Yes or no? So let me show you first that how EtherChannel will avoid loop. So see, suppose I have a switch 1 over here, I have a switch 2 over here. Suppose MAC address is 0A, MAC address is 0B. You can consider anything, right? Suppose we have only 2 link, right? I am connecting only 2 link to make you understand, right? Only. Suppose this is 0/0, this is 0/0, this is 0/1, and this is again 0/1. Fine. So if you have bundled these 2 link together, right? Suppose this is my P1, this is also my P1, right? This is logical port. Here suppose we have some user, okay, whose MAC address is suppose A. Here also we have one computer whose MAC address is B. Suppose IP address of this machine is 10.1.1.1, IP address of this machine is 10.1.1.2. Fine. Now if this machine ping to this machine, so source MAC will be what? Source MAC will be A, destination MAC will be what? Destination MAC will be B, source IP will be what? 10.1. But you know, this machine don't know the destination MAC address, right? So this machine needs to generate what? ARP, ARP protocol, address resolution protocol. So first of all, this machine will generate what? ARP. And as you know, ARP is a broadcast frame, right? So this broadcast frame will be received by this switch over here. Yes or no? Now when this switch will receive this broadcast, first of all switch will learn source MAC address on this port. Suppose this is 0/3 port, so it will learn so MAC address A on 0/3 port. After that it will check destination. So destination is what? Broadcast. Destination is broadcast. It have P1 logical port, so it will forward from P1 port. But you know, to forward traffic, definitely EtherChannel will use physical link. Yes or no? So if destination is broadcast, it will forward from this port also, and it will forward from this port also. No. When we will discuss the when we will discuss load balancing, then you will understand how switch 1 will forward broadcast traffic, right, on EtherChannel. But first of all, see, if this switch will send broadcast from this port, and when switch 2 will receive this broadcast from over here, right, what this switch will do? See the internal algorithm of loop avoidance of EtherChannel. what this switch will do, this switch will receive the broadcast frame on this port, this is 0/0 port. So switch will check that 0/0 port is member of which port channel group. So this port is member of which channel group? Channel group 1. So it will never forward this traffic from the port which is member of same channel group. So this port is also member of same channel group. That means this switch is not going to forward this broadcast from here. Yes or no? So this is how EtherChannel will avoid loop. Yes or no? What I am saying, whenever switch will receive a broadcast frame on any interface, it will check that interface is member of which channel group, right? And this port is member of channel group 1. So it will not forward this broadcast message from the port which is member of same channel group. Suppose here we have one more switch, this port and here also I have created loop EtherChannel, and this is suppose P2. So it will forward from this port, right, this broadcast message, because this port is member of another port channel, and traffic which I am receiving is broadcast. Then definitely I need to forward from the all other interfaces, but not from the interface which is member of same channel group number. Okay, this is how EtherChannel will perform loop, how EtherChannel will avoid loop in the topology, right? This is how EtherChannel will create loop free topology. And here suppose between I have two switches, I have 4 link, right? I have bundled these 2 link together, and I have bundled these 2 link together, right? Now I have P1 and P2, right, on switch 1. On switch 2 also P1 and P2. Now again STP will do what? STP will block this link, this port P2. So again loop will not form. So if you have 2 channel group between switch 1 and switch 2, then STP will block 1 channel group, right? STP will block 1 channel group. But in 1 channel group, suppose if you have 4 link or 8 link, STP is not going to block a single link. Okay, now guys, this is why we come up with EtherChannel. And what is EtherChannel? So what is EtherChannel? EtherChannel is a technology which is used to aggregate multiple physical link into a single logical link. We can bundle multiple physical link together to get the maximum bandwidth between switches. Yes or no? This is the actual concept why we come up with EtherChannel and what is EtherChannel. Now let me discuss how many methods we have to configure EtherChannel. This is very important. How many methods we have to configure EtherChannel, right? First one is static, right? We can manually configure EtherChannel between switches. Second one is dynamic. In dynamic, again we have 2 protocol. First one is PAGP. PAGP is an Cisco proprietary protocol. Cisco proprietary protocol. That means we can configure PAGP only on Cisco devices. Here in static we have one mode, that is on mode, right? With this mode we can configure static EtherChannel. We had already discussed these things. These are very basic things, right? After that, in PAGP we have 2 mode. We have 2 mode. One is desirable, and second one is, this is A, and B is desirable and auto. Guys, desirable is similar like dynamic desirable port in DTP, right? Desirable port will always initiate the EtherChannel negotiation, right? To form EtherChannel, auto mode cannot initiate the negotiation. Only desirable mode can initiate the negotiation to form EtherChannel between switches. So in PAGP we have 2 mode. One is desirable and one is auto. Means desirable and desirable can form EtherChannel. Yes or no? But auto and auto cannot form EtherChannel. Yes or no? In the same way, auto and desirable can form EtherChannel because it will initiate the negotiation, and desirable and auto will also form the EtherChannel, right? Second type of dynamic is LACP, and this is the protocol which nowadays we are using, LACP. Here in static we can bundle up to 8 links together only. 8 links together, right? Suppose you have more than 8 links between switches, right? You cannot configure, you cannot use this method, static method. In PAGP also we can bundle max to max 8 links only, right? in LACP, it is an, first of all, it is an open standard protocol, right? So on Cisco devices only you can run PGP. Suppose you have a Cisco device and you have a non-Cisco devices, right? Here you need to configure EtherChannel. Here you cannot use PGP protocol, right? But suppose this is non-Cisco device, this is Cisco device. Here we can use LACP because it is an open standard. Here also we have two modes. First one is active and second one is passive. Active and passive. Active is similar like desirable and passive is like auto. Active will always initiate the negotiation and passive will always wait. And here in LACP we can bundle up to 16 links, right? But there will be 8 links in the active state and 8 links will be in standby state, right? Like for backup. Means here we can bundle up to 16 links, but there will be only 8 active link, right? 8 will be the standby. Now there are lots of questions. I know lots of questions is coming in your mind from here, that how 8 links will become active, how 8 link will, which ports will become active, right? So there are some criteria, right? So guys, now topic is directly I am going to discuss LACP. I don't think that you need to learn much about PGP because here there is nothing. It is a Cisco proprietary protocol and nowadays we are not using as well, right? We have two modes to configure. Directly you can go to interfaces and you can run command like channel group, after that group number, mode, or you can set desirable. Automatically EtherChannel will form between switches, yes or no. Here important is LACP protocol. So this protocol I am going to cover here in detail. Here only I am going to make you understand load balancing. Then definitely you will understand the load balancing on PGP also. But you know, in PGP we cannot achieve load balancing, right? But today I am going to make you understand the load balancing, right, of EtherChannel. Maybe in future there will be one more protocol, right, which will provide load balancing. So how that protocol will use load balancing algorithm. This is what I am interested to make you understand. Okay, so let's start from LACP protocol. LACP. It is an open standard and we can bundle up to 16 link together. Guys, suppose I have two switch. Let me draw larger switch here, right? Okay. Suppose I have two switch. This is suppose switch 1. This is suppose switch 2. Okay, we have suppose 16 link. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and let's say 16. We have 16 link between switch 1 and switch 2. Let me give the numbering as well. Suppose this is port number 1, port number 2, port number 3, port number 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16. Here also 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, we have 16 link between switch 1 and switch 2. Suppose switch 1 is connected with one router here and this router is connected with suppose ISP. Okay, like this. This is my topology. Fine. And here suppose we have some computer user. Okay, suppose MAC address of this machine is A, MAC address of this machine is B, MAC address of this machine is, let's suppose, C, and MAC address of this interface is suppose ABC, let's say E. Okay, MAC address of computer is A, MAC address of this computer is B, MAC address of this computer is C. Suppose IP address of this computer is 10.1, IP address of this computer is 10.2, IP address of this computer is 10.3. IP address of this interface, right, is suppose 10.100, right? So this IP address will become default gateway for all user, yes or no? So now here in between switches we have 16 links, so 8 link will become what? Active. So which 8 link will become active and which 8 link will become standby? Guys, for that we have a concept in LACP, that is nothing but LACP port ID. port ID. LACP port ID. What is LACP port ID? Again, LACP port ID is combination of two things. First thing is priority, and second thing is port ID. Port ID by default priority is 32768, and port ID is, as you can see. So what will be the port ID of this port number 1? Port ID of port number 1 will be 32768 plus 1, right? So it will be dot 1. Port ID of this port will be what? 32768.2. Port ID of port number 3 will be what? 32768 plus 3 means dot 3. Port ID of port number 4 will be 32768.4. Port ID of port number 5 will be 32768.5, right, like this. And first 8 lower port which will have lower port ID, LACP port ID will become active. So port ID of this port will be this one, port ID will be this. So first 8, like port number 8, these all ports will become what? Active, because these all ports have lower port ID than these port. Yes or no? So these port will become what? Standby, and this port will become what? Active. Got it? Are you getting my point? What I am saying, that if we have 16 link between switch 1 and switch 2, how switches will decide that which port will become active and which port will become standby? Because up to 8 link can be active and 8 link will be in standby. For that we have a concept of LACP port ID. LACP port ID is nothing but the combination of two things. First one is priority and second one is port ID. By default priority is 32768, and port which will have lowest port ID will become active, right? So these 8 port have lowest port ID. So these 8 port will become what? Active. Guys, but here is one question. Suppose, let me change the port number. Okay, here also this port will become active, and here also this port will become active. Now what I am seeing, let me remove this one as well. Okay, now on this switch number 1, this is my port number 16, this is my port number 15, this is port number 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Right? And here this is my port number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16. Okay, like this. So on switch number 1, these port will become what? Active. And on switch number 2, these port will become what? Active. Yes or no? So now switch number 1, if these ports are active, and switch number 2, if these ports are active, so when user will send traffic, it will use these link. Yes or no? These port to forward traffic. Suppose switch number 1 is forwarding traffic from this port. Guys, we are going to understand how switch will perform load balancing. Just wait. But suppose now switch is forwarding traffic from this port, right? And on switch number 1, this port is in standby, right? So it will discard the traffic. Then how communication will happen? No, guys. Never switches will select active port and passive port like this, right? This is completely wrong. Let me draw same diagram again. Again, this is my router, and my router is connected with one switch. Here I have another switch number 2. This is switch 1. This is switch 2. Again, we have 16 port. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Right? Suppose this is my port number 16. This is 15. This is 14, 13, 12, 11, 10, 9, 8, 15, 48, 7, 6, 5, 4, 3, 2, 1. Right? Suppose this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16. Fine. Suppose these are port. Now see how active and state by election will happen. For that we have a concept in LACP, and that is nothing but the system ID. System ID. And you know, system ID is combination of again two things: priority plus base MAC address. base MAC address. By default priority is again 32768 plus, sorry, 32768, and base MAC address, as you know, all switches has a unique MAC address, right? That is nothing but base MAC address. So suppose base MAC address of this switch is 0A, base MAC address of this switch is suppose 0B. So what will be the system ID of this switch? System ID of this switch will be 32768 plus 0A. What will be the system ID of this switch? 32768 plus 0B. Now switch which have lowest system ID will decide that which port will become active and which port will become standby. What I am saying? For the active and standby election, we have a concept in LACP that is nothing but system ID, and system ID is combination of two things. First one is priority and second one is base MAC address. Priority is by default 32768, and as you know, base MAC address is MAC address, unique MAC address of switch. So switch which will have the lowest system ID, that switch will decide which port will become what, active, and which port will become standby. So this switch have lowest system ID. So this is the master switch, this is the main switch, right? This is your main switch. Like in STP, as you know, there is one main switch that is nothing but root bridge switch. In the same way, in LACP also, one switch will become main switch which will have the lowest system ID, and this switch will decide which port will become active, and it will use same concept, this concept, LACP port ID. This switch will decide, right, by using LACP port ID. So according to this concept, these 8 port will become what, active, right? So this switch, this is not main switch, this switch will also negotiate these port and it will make these port as active. Fine, got it? And these 8 port will become what, standby, here also and here also, right? Standby. Clear, guys? Now hope it's clear to you that how switches will perform active and standby election. Now I am going to make you understand load balancing. That is very important, right? Many time interview is asking question from load balancing, that how LACP will perform load balancing. Okay, so let's see, guys. Let me check that what video is recording or not. So yes, it's working fine, no problem. Now to understand load balancing, what I am going to do, let me draw the diagram again. Entire thing I am going to remove, and let me design same topology again. Okay, so this is my again switch 1. It is very important concept. Okay, please try to understand very carefully. Switch 2. And you know, if you want to learn EtherChannel very detailed, right, like if you don't know PAGP, LACP, right, these things, so what you can do, you can enroll in the live training, right? I am going to start CCNA batch from 10th of March. There you can enroll and you can learn each and everything from beginning to advanced. It's my responsibility how to make you understand everything in just 45 days, right? So I will make you understand everything in 45 days. You will be perfect to get job in top MNC company, right, within 45 days. Okay, so if anyone is interested, you can enroll, right? I am allowing only 10 students in one batch so that we can interact. Okay, now this is my switch 2. Okay, let me connect some cable between switches 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16. Got it? Port number, suppose it is 1, is 2, this is like 0/1, 0/2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15, 16. Okay, this is also 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16. Got it? Suppose MAC address of this switch is 0A, MAC address of this switch is 0B. So this switch will decide which port will become active. So these 8 port will become what? Active. Right? These port will become what? Standby. So first thing that I would like to tell you over here is, suppose this port will goes down, port number 5 or port number 6, any port from the active will goes down. So one port from the here will become what? Active. And again suppose port number 5 is down now. So port number 9 will become what? Active, because port number 9 have lower port LACP port ID than port number 10. So definitely this port will become active. And again, if port number 5 will come up, guys, election will not happen. Still this port will become what? Standby, right? Until and unless active will not goes down, right? Not any standby port is going to become active port. Fine. Now this is connected with one router. Here IP address is 10.100 and MAC address is E, and this router is connected with same like ISP. So we have multiple types of load balancing algorithm, but by default the algorithm which is running on switch for load balancing is source MAC address. What? Source MAC address algorithm. We have multiple, we have 8 types of algorithm, right? Like source MAC, based on source MAC load balancing algorithm, based on destination MAC algorithm, based on source and destination, source port, destination port, source port, destination port. These are the algorithm, right? But on the switches by default we are using source MAC algorithm to perform load balancing. Now we have some computer over here. PCA, PCB, and let's say only 3 PC. We have 3 PC. Suppose MAC address of this machine is A, MAC address of this is B, MAC address of this machine is C. IP address of this machine is suppose 10.1, 10.2, 10.3. Suppose this user wants to ping 8.8.8, right? Means this user want to access what? Internet. So source IP will be what? This one, and destination IP will be what? 8.8.8.8. Source MAC will be what? A, and destination MAC will be what? E. MAC address of default gateway. Now the algorithm which is running on switch to perform load balancing is what? Source MAC, right? And how many link are active between switches? 8 link are active between switches. Tell me, to represent 8 link, how many bits is required? We require 3 bits, right? To write 8, to represent 8 links, we need 3 bits only. Yes or no? Because suppose you want to write 8 in decimal, right? In binary, how you will write it? 1 1 1. It will be what? It is what? 1. It is what? 2. It is what? 4. So 6 1. It is 7. Right? We need 3 bit to represent 8 link. Yes or no? Because 1 is 0 0 0 0. This is 0 0 0 1. This is 1 and 1 1 1 1, like this. This is what? 7. So how many decimal number are there? 7. Right? So to represent 8 links, we need 3 bits. So what switch will do? Switch will convert the source MAC address, because here the algorithm which I am running to perform load balancing is source MAC. So whenever switch will receive any frame, it will convert the MAC address, source MAC address in binary, and it will use last 3 bit to perform load balancing. What I am saying, suppose this user wants to ping 8.8.8. What will be the source? Source will be 10.1, destination will be 8.8.8. We don't need to do anything with that, right? So what will be the source MAC? Source MAC will be A. What will be the destination MAC? Destination MAC will be E, right? One switch will receive this frame on this port. Suppose this is my 0/21. This is 0/22. This is 0/23, right? Anything. Now when switch will receive this frame over here, it will convert this MAC address into binary, right? So in last, it will use only last 3 bits. So what will be the binary of A? A means what? 10. So in binary it will be 1010, and it will use last 3 bits. So last 3 bit is 010. What will be the decimal value of it? Decimal value of it will be 2. Yes or no? So switch is going to use port number 3, right? What I am saying, switch is going to use port number 3. See here I am going to write you, if last source MAC address is 000 in the last 3 bits, then decimal value will be what? 0. So it will use which port? It will use port number 1. Suppose in the last 3 bits value is 001. So decimal value will be what? 1. It will use port number 2. If last 3 bits is 010, decimal value will be 2. It will use port number 3. So it will use port number 3. If the binary bits is 011, decimal value will be 3. So it will use port number 4. If value is 100, it is in decimal value will be 4, so it will use link number 5. If value is 101, decimal value will be 5, it will use port number 6. If last 3 bits is 1 and 10, so decimal value will be 6, so it will use port number 7. If value is what? 111, decimal value will be 7 and it will use port number 8. Got it? So this is how switch will perform load balancing. Okay guys, so tell me, when this user will ping internet, which link this switch will use? Switch 2 will use this link. Which link, right? So tell me what will be the last 3 bits of binary, right? So A means 10, it will be 010. Yes or no? 010 means decimal value is 2, so that means it will use which link? It will use link number 3, right, to reach internet. When this user wants to reach internet, this switch will use which link? See, source MAC is what? B, so it will convert B into decimal. B means what? 11. 11 means 1. How to write 11? 1 0 1 1. It will be the binary, right? It will use only last 3 bits. What will be the decimal value of 011? 011, it will be 3. So it will use which port number? Port number 4. So it will forward the frame from this port. Yes or no? What will be the port for PC number 3? So see here, source MAC is what? C. Source MAC is C. That means in the bits, what will be the value? Last 3 bits. Guys, C means what? It is 12, right? And if you will convert 12 into binary, value will be 8 plus 4, 0 0, right? So value is this one, 100 100, right? Decimal value that you will get is 4. That means it will use link number what? 5. Got it? This is how switches will perform load balancing, guys. But there is some problem. Are you able to understand the problem? For the traffic, when these user will generate traffic for internet, definitely switch will perform load balancing. But when ISP will generate reply every time, source MAC will be what? Suppose this machine is pinging 8.8.8, so it will generate request. Source MAC will be A, destination MAC will be E. But when reply will come, right? Then here, when this router will forward the frame to this switch, this source will be E every time. Source will be E for this user as well. For the reply of this user also, source will be E. For this user also, source will be E. That means for replying, right, for the traffic which is coming from router to inside, switches will not perform load balancing, because every time source port will be what? E, right? So it will use which link? E means what? 14. So what will be the binary of 14? It will be 8 plus 4, 12, and 12 plus 2, 14, right? This one will be the binary. So 110, decimal value will be 6, so it will use link number 7, right? So reply will come via this link. Yes or no? To this user also, to this user also, and to this user also, right? So for replying, when this machine will receive reply, it will receive by this link. When this user will receive, it will receive by this link, right? Suppose there are 1000 users, right? So for 1000 users, switches will use only this link, right? For the traffic which is coming from router to switches, right? Yes or no? Because every time source will be E. So still switches is not performing load balancing for what? For the traffic which is coming from router to switch. So here we need to change the algorithm. Here we need to change the algorithm. Here we are using what? Which algorithm? Source MAC algorithm. So if you want to perform load balancing for both, you need to use what? Source and destination MAC algorithm. Source and destination MAC algorithm. If you will use this algorithm, then switches will do what? Switches will convert both MAC address, source MAC as well as destination MAC. See, suppose this switch is going to send traffic to router 8.8.8. Source MAC will be A and destination MAC will be what? E. This time, this switch is going to, when switch will receive frame, this switch is going to convert in binary to both MAC address. What will be the binary of A? Binary of A will be what? 1010. What will be the binary of E? Binary of E will be what? Binary of E will be 1110, right? So it will use only these 3 port. So source binary is 010 and destination binary is 110, and here switch will perform XOR. As you already know, XOR means what? When value input is 1 1, right, output will be 0. When input is 0 0, output will be what? 0. When input is 1 0, output will be 1. When input is 0 1, output will be 1. So tell me, 0 1 will become what? 1. 1 1 will become what? 0. 0 0 will become what? 0, right? So now tell me what will be the decimal value of this binary. Decimal value of this binary will be 4. So it will use link number what? 5 here. Now this time, if you are using source destination MAC algorithm, this switch will forward traffic of computer A from port number 5. Yes. When reply will come, source will be what? E, and destination will be what? A. Again it will use same link because value you will get is same. But when this machine will generate request, right, source will be B and destination will be E. B and E. Now tell me, you tell me in the comment which link switch will use to forward the request and which link switch will use to forward the reply, right? Now it is using, switches are using both source as well as destination, right? So this is load balancing. Hope it's clear to you, right, how switches will perform load balancing in LACP. So by default it will not perform load balancing for the traffic which is coming from router to switches, right? It will perform load balancing from switches to router only. So if you want to perform load balancing for both, you have to change the algorithm. You have to set algorithm source and destination MAC. Okay guys, now from, I think from last 1 hour I am speaking, so it is difficult to discuss more thing, and I don't think that there is more concept, right? Here is more concept left, because these are the concept only which interviewer is asking, right, to interviewer, and these are the concept which nowadays we are using in the real time. So make sure if these things is clear to you, you can easily crack the interview, right? If you are already a network engineer, try to use these things, try to identify these things in the real environment, in the production environment. Definitely you will get benefit, you will get promotion, you will get hike in your salary as well. Okay. So most of the people are saying I am not getting, my resume is not getting shortlisted, I am not getting promotion, right? I am not getting much growth in the networking industry. So this is the reason why, because people don't have the deep knowledge. People have knowledge of configuration only, right? That how to configure EtherChannel. You should have knowledge that how to perform load balancing for both, right? How to change the load balancing algorithm. And you know, I am make one practical video as well on it, right? And that will make you understand the configuration part, how to configure these things. Okay. Now one more thing I want to discuss over here, that is, let me show you, layer 3 EtherChannel. So this is layer 2 EtherChannel. Till now we had discussed layer 2 EtherChannel only, right? Now guys understand layer 3 EtherChannel. Okay. So suppose I have one switch here, I have one switch over here, switch 1 and switch 2. Okay, suppose we have one computer over here whose IP address is 10.1.1.1. I have one computer over here whose IP address is suppose 20.1.1.1. Okay, we have one link between switch 1 and switch 2. Guys, if you will configure this link as trunk, right, communication between 10.1 to 10.2 will not happen. These are L3 switch, L3 switch, L3 switch. This is your L3 port, but by default it will work as L2. So you have to manually configure this port as L3 port, L3 port, right? How? You will run command like no switch port. By running no switch port command, you can make any L2 port to L3 port. So you will run no switch port command over here, right? Then if you want to make communication possible between these two users, what you need to do? You need to create SVI, sub virtual interface, over here, right? You have to assign one IP address on the VLAN interface. Like suppose this port is member of VLAN 10 and here I have configured IP address 10.100, right, on the VLAN interface. Here also I have created one SBI for VLAN suppose 20 and here IP address is 20.100, right? Now tell me, in the routing table of this switch, This is layer 3 switch, right? This switch can perform routing as well. Just you need to write one command in global config mode, that is nothing but IP routing to enable routing, right? Then you can check the routing table. In the routing table of this switch, there will be only this network 10.1.1.0 network. In the routing table of switch 2, there will be only this network 20.1.1.0 network, right? Okay. So if you want to perform routing between switch 1 and switch 2, what you can do? You can configure any dynamic routing protocol like EIGRP. Suppose I have configured EIGRP 100 over here and EIGRP 100 over here. So do you think that these switches is going to share their exchange their routes? No, because when you will configure EIGRP over here, it will generate hello message. Yes or no? It will generate hello message. It will forward hello message from which interface? From the VLAN 10 interface, right? From this interface, or from, as you know, this is trunk interface, so it will forward from here also, right? From here also it will send, and EIGRP neighborship will form between switch 1 and switch 2. Or what you can do here, also you can configure one IP address. Suppose this is L3 port, and here I have configured IP address 12.1, here I have configured IP address 12.2. So now we can configure EIGRP 100 to share these prefixes, right? It will form neighborship. Yes or no? Yes or no? So what will happen if this link will goes down? Again, there is problem. If this link will goes down, there is no connectivity between switch 1 and switch 2. So you will use one more link over here. Like suppose I have two link between switch 1 and switch 2. Between both L3 switches we have two link, or suppose we have 4 link, and you are running EIGRP for the route exchange. How many hello message this machine will generate? 2. How many neighbor will be there? 2. How many hello message this switch will generate? 2. How many neighbor will be there? 2. Right? Suppose there are 8 link, guys. So it will generate 8 hello message, right, after the hello interval. It will also generate 8 hello message after the hello interval time. It will receive 8 hello message. Yes or no? And as you know, whenever switch will generate hello message and whenever switch will receive hello message, when switch will generate hello message, it have to perform encapsulation. When switch will receive hello message, it have to perform decapsulation. Every time when switches will perform encapsulation and decapsulation, switches will use their CPU, right? So after hello interval, every time switch will send 8 hello message and will receive 8 hello message, maybe CPU utilization of switch can be high. And if CPU utilization will high, then performance will what? Low. So this is problem. What I can do over here? I can bundle these two links together, right, with the help of EtherChannel. This is nothing but the layer 3 EtherChannel. Suppose here I have bundle it to P1, this is my P2, and on this port I will configure what? EIGRP. Now how many neighbor are there? Only one. How many hello message it will create? Only one, right? So this is what? Layer 3 EtherChannel. Okay guys, I will show you practical of this, that will make you more clear, right? So for now, this is all about the today. If you learn something from this video, guys, please hit on like button, right? If you haven't subscribed my channel, please subscribe this channel. We will meet soon in next video. Till then, stay safe. Bye bye guys.